Researching a migratory species has its challenges. Oceanic manta rays, as their name suggests, spend a large proportion of their lives in deep oceanic waters. Migrating hundreds, if not thousands of kilometers seasonally, these animals pay no attention to international borders or jurisdictions. This makes conserving these animals even more challenging. To conserve these animals, we must first find out what habitat they are using, when they are using it, and why.
Animal telemetry, otherwise known as tagging and tracking, has become an incredibly useful tool for scientists and policymakers in advancing the knowledge and conservation of migratory species.
These can include satellite tags, which are attached to an animal and have an internal computer that can continuously record lots of environmental data, such as temperature, depth, light levels, and GPS location.
It can also include acoustic tags, which emit signals that are picked up by underwater receivers every time an animal passes within 200 meters of a receiver. Satellite tagging is useful for broader scale animal movements, whilst acoustic tagging is more suitable for fine scale movements. We can even use CRITTERCAMs, animal-borne video cameras that provide direct observations of manta ray behavior at depth.
Whilst photo identification is an extremely useful and inexpensive tool for studying manta ray populations, the data collection is limited to scuba divers and snorkelers, thus limiting the data to shallow reef systems. Therefore, once the rays leave the sites, we have no idea where they are going or what they are doing. Knowledge which is critical if we are to effectively protect this species.
Previously, our teams have been able to suggest the crossover of mainland Ecuador's oceanic mantas with those of the Galapagos using satellite telemetry. Now we want to better understand if there is a connectivity between marine protected areas in Ecuador.
During this expedition in Ecuador, the Proyecto Mantas Ecuador project have been deploying satellite and acoustic tags within the critically important habitat Isla de la Plata.
They have acoustic receivers in both Isla de la Plata and Bajo Cope Marine Reserve, another manta aggregation site further south, which is more isolated and remote than Isla de la Plata.
Previously, we have found movement between the two areas, and that manta rays are staying in Isla de la Plata and Bajo Caupe for a period of time before migrating south into Peruvian waters.
The tagging efforts from this trip will provide us with a better understanding of the manta ray movements between these protected areas and throughout the region, in turn improving our knowledge of management priorities for these locations and the migratory routes between them.